we are going to start the complex trinomial section off with the area model. So as we learned in the last section, when we're given a trinomial like this, we're given the area. So this area can be represented by 3x squared plus 7x, but we don't usually deal with the 7x or this middle term until the end. We jump right to the end first. So we're going to have plus 2 here. Now this plus 2 can be arranged like this or like this. We have to think about which arrangement gives us 7 x's. So if I put these side by side, I can kind of picture that one x will be here and another x will be here. So that's 2, 3, 4, 5. Okay, well that's not the 7 that I need. Whereas if I align it the other way, then I'll have 1x here. And then I'll have 6 of them in this arrangement, right? Let's see here. So you can see that. Jumped ahead there, so saved you the monotony. All right, now that we have the area model that matches what we were given, the expression we were given, factoring is taking that area model and breaking it down into its length and its width. So its length is going to have 1x, 2x, 3x, and 1. Okay. So this part accounts for 3x and a positive 1. Just remember that these tiles, this is x by x, this is 1 by x, and this is 1 by 1. Okay, just for these purposes. The width is going to be x plus 2. X plus 2. And we can double check that this is the right area by expanding it. Okay, so if we multiply the length times the width, we should get the area expression that we had. So 3x times x and 3x times 2, that's 3x squared plus 6x, and then we have 1x, and then times 2 we have x plus 2, and then we can see that this is going to give us 3x plus 7x plus 2. All right. Now normally, if we weren't using this area model, we weren't using this visual, we would look at this and say, what numbers multiply to give me 6? So we'd multiply the two outside numbers, okay, and also add to give me 7. That's what we would do. Okay, and so we would get 6 and 1. Okay, do we see 6 and 1 here? Aha, here it is, 6 and 1. So we are looking, when we are doing that, what multiplies to give me this and adds to give me that, we're looking for how are we arranging this rectangle. Okay, and that's why it's so important to decide and start with these two. Okay, so you start with those two, recognize the options that you have, and then pick the one that best suits your area model. We're going to try an example. We're going to try and do this without the visual. Okay, we're going to use some negatives. Okay, so we know that we need 2x squared as our little section here, and we need a negative 3 here. So what multiplies to give me negative 3? Okay, well it's either negative 3 and positive 1 or positive 3 and negative 1. So the question is, what arrangement do we need in order to figure out what's happening here? Okay, so let's tie this into what we know. We know we have to multiply these two things. Okay, so it should multiply to give me 6, specifically -6, because 2 times -3. And the two numbers that we need should multiply to give me, add to give me -5. Okay, so what's going to add to give me -5, but also multiply to give me -6? It's not -2 and -3, because that's two negatives. That would give me a positive if I multiplied. So it must be -6 and +1. Okay, so that means we want to have 6 x's, -6 x's in one area and 1 x in the other. All right, well, how are we going to do that? This can't be here then. This must be a 1. Okay, and it has to be positive because this has to be positive. And if this is going to be an x, then this has to be an x, because 1 times x would give me this area here. To get this area, 2x squared, I'd have to multiply x by 2x. So that must be 2x. There we go, I have my length already. And this 1 down here can't be there, because if I'm going to multiply 2x by something to get -6, it must be negative. It's got to be -3. So I have 2x plus 1 and x minus 3. Okay, so we're kind of combining all of the different methods together. Okay, if this was a little confusing, I'm going to go back to the other version where we use our area model. Okay, so if it's going to be 2x squared, I'm getting this from my original expression, 2x squared, and it's got to be -3. Okay, well, we decided it must be 1 by 3. Must be this version, because then that gives us the right amount. I'm using positive when it should be negative. Gives us the right amount of x's. So -6 x's and 1x. So these two cancel, okay? So a positive x and a negative x cancel, which allow us to have our -5x, and we have our -3. So there's the model there. So last piece, we're going to look at this algebraically. Okay, so we just looked at box method. That's done. Okay, so decomposition, if you're comfortable, okay, this is where we're headed. We're looking for two numbers that multiply to give us 6, -6. This was a negative, wasn't it? Yep. And add to give us -5. And we already decided that those two numbers were -6 and +1. So we can also decompose or break up the center term to be -6x and positive x. Sorry. So -6 and +1 minus 3. The next step here is to group these terms and common factor. Okay, so I'm going to common factor. We learned about that in the first video. I'm going to common factor out an x, and now I'm looking at my 2 and -6. Okay, so I can also take out a 2. So that's what I'm taking out. And this is what's left behind. Okay, all right, so there's nothing really common about x and minus 3. So I could use a 1. Okay. What's left? X minus 3. Now this doesn't look like 2x plus 1 times x minus 3 like we had in the other question, but we can kind of see it. Okay. So there's actually a common factor here. So I am going to take out an x minus 3. I'm going to factor it out. And what I'm left with is 2x plus 1. And there's my length and my width that we saw here. Okay, we saw it here. I just want to point out one more thing, and that's that if we were going the other direction, okay, so if we were expanding x minus 3 and 2x plus 1, we'd have 2x squared minus 6x plus x minus 3. See how these are the same thing? So you're working backwards. You're splitting up the term, and then you're splitting up the expression. Okay. So I just want you to see how, again, expanding and factoring are opposites. Okay. So you do whatever combination of these things works for you, but you're only going to know that if you try it. Okay. There's so many things out there like Photomath and Wolfram Alpha and Desmos. You can also use the Maths tool in OneNote, and it will do this factoring for you. But it's really important that you understand what factoring is. So how you factor is less important than knowing what you're getting when you're done factoring. Okay. Good luck with your factoring.